In this video, we will talk about the latest installment of GLASSgo, which is a Homolog Finder for small RNAs, and we'll show how to use GLASSgo within the workflow platform Galaxy. This is the first part in which we'll learn how to install and set up GLASSgo for Galaxy. And in a separate video, we will work on a real use case. GLASSgo can be used in different ways. The integration of GLASSgo into Galaxy is based on a Docker container. Therefore, we provide GLASSgo together with all its dependencies as a Docker container and distribute it through DockerHub. This Docker container then can also be used for command line analysis or for the integration into custom analysis pipelines. We will talk about this approach. As Galaxy now supports running tools within Docker containers, GLASSgo can be installed to any local Galaxy instance using the Galaxy Toolshed. Furthermore, GLASSgo is now also ready to use on one of the public Galaxy servers. And finally, the GLASSgo web server can also be used to perform analysis using GLASSgo. Further information about the installation and setup discussed in this video can be found at the GitHub GLASSgo repository. Similarly, the principle of GLASSgo itself can be read in the most recent publication. What's new in GLASSgo 1.5.2? We added the possibility to report upstream regions of the found sRNA homologs, as this allows to infer possible promoter elements. In order to make use of the latest NCBI databases, GLASSgo now supports the use of NCBI session numbers as unique identifiers. This adaptation makes it necessary to create new lookup tables for the taxonomic classification. This is a prerequisite for clade-specific searches that are often more powerful than untargeted analysis. And these lookup tables are stored at an open access repository for which we provide this link here. So let's begin by installing and setting up GLASSgo using Docker. At first, we have to retrieve the GLASSgo Docker image and start the image as a container. In doing so, we use Docker volumes to share data between the file system and the container. We begin by pulling the GLASSgo Docker image from DockerHub. When we now start the GLASSgo container, we need to provide it with the accession lists, the input sRNA, and the BLAST database. This means we will create shared volumes that share this data from the local file system to the Docker container. And in doing so, we recommend using separate folders for all of them to simplify the amount of the data into the container. Here we downloaded all the accession lists into the folder acc_lists. Likewise, we deployed the input files into the folder sRNA_input. Here we have only one file. This is the NSIR4 FASTA file, which contains a single sRNA sequence. And lastly, the BLAST database is located in this folder. Now we list all the available Docker images on the file system, and here we see the one for GLASSgo. It's common practice to also create a folder for the results. And now we can run the GLASSgo image as a container. For this, we simply type in docker run, and using the option -v, we can now also share folders between the file system and the Docker container. For that, just type in the local folder, a colon, and the target folder on the container. And obviously, we're doing this for the BLAST database, the accession lists, and the input and output folders. Finally, we provide the ID of the Docker image and start the container. Typing in docker ps lists all the active Docker containers, and we can see that the GLASSgo container is ready to use. And that's all there is to it in terms of installation and setup. And now we can start the analysis with GLASSgo. This is done using the docker execute command, which is followed by -it that will invoke an interactive bash shell on the container, the image ID of the container, and the GLASSgo call itself. We then specify the BLAST database using -d, the input file using -i, the accession list using -g, and the output file using -o. We hit enter and start the analysis. So this is done, and now we can go to the output file we specified and look at the results. Now we'll talk about how this Docker container can be integrated into Galaxy and how this provides a more user-friendly interface than the command line. We start with configuring the BLAST database. In other words, Galaxy has to be made aware of it. And this is a general approach that holds true for all tools in Galaxy that utilize this database. In the next step, we will want to install the GLASSgo Galaxy wrapper using the Toolshed, and finally we want to incorporate the accession lists using a custom script. At first, let's make sure that the BLAST database is located somewhere on the file system. Now we go to the folder of our Galaxy instance and head to the tool data directory. Within the tool data directory, there is a file named blastdb.loc.sample. If the blastdb.loc doesn't exist yet, we just create it by making a copy of this file without the sample ending. Now we want to edit the blastdb.loc and add an entry for our BLAST database. The format for this entry is simply the identifier, in this case NT, which is then followed by the caption, and this is actually how it occurs in the tool interface and is then followed by the path to the database. Now we have to edit the jobconf XML file that is located in the config directory of Galaxy. If this has not been done before, we add a runner for Docker containers. Just insert a new destination tag using the ID docker_local. This has to be actively enabled, for which we insert this parameter tag here. Similarly to the Docker setup, we want to share the BLAST database as a volume to the Docker container. And this is done by this parameter tag here with the ID docker_volumes. Finally, we set Docker as the default runner and we're done here. Now we can start up Galaxy and install GLASSgo using the Galaxy Toolshed. We will click on the admin panel, install or uninstall, and search for GLASSgo. Click on the entry and select install. In this menu, you can select a specific tool section in which GLASSgo should be listed within Galaxy. With this, we have successfully installed the GLASSgo wrapper, and finally, we have to integrate the accession lists. For that, we go to the folder in which GLASSgo has been installed to. In here, we will use the tool config lookup. So type in config lookup and provide it with the path to Galaxy. Optionally, it is also possible to specify the folder to which the accession lists are downloaded to, and the default is just a subfolder within this installation directory. That's all there is to it. Restart Galaxy and GLASSgo is ready to use. In principle, just upload the single sRNA sequence, and then just search for GLASSgo. Here it is. As before, select the uploaded file, the accession list, and click on execute. And in the next video, we'll talk more about the usage of GLASSgo and discuss the parameters.